So, as we have already discussed in the theory that transistor can either work as a switch or as an amplifier. In this lab, we will understand that how transistor works as a switch in cutoff and saturation region, and we will simulate this circuit on multisim. This whole actually contains the theory which we have already discussed, such as a transistor is a two junction, three terminal semiconductor device. The names of these regions are emitter, base, and collector. There are two types, NPN and PNP. Similarly, uh, as per their doping, emitter is heavily doped, base is thin, lightly doped, collector is moderately doped, and its largest in size or thickness. So, anyways, this handout is uploaded. This is the representation of the transistor in hardware. C stands for collector, B for base, E for emitter. This is the symbol for a NPN transistor. If this will be PNP, so arrow will be in, and these two circuits actually demonstrate how it works as a switch when it's on and when it's off. And the same thing we will try on the multisim. So uh, this is the part where we apply the input and it's the base. So if zero voltage is applied, so base current will be zero. If base current is zero, so there will be no current in the collector side, and this region is cutoff region in which transistor will act as an open switch. So this is the equivalent circuit, and transistor is working as a switch open or off. When we will apply some base current, there will be flow of current in the collector side, and the transistor will act as closed switch or switch on. And this same thing we will see in the multisim. So two types uh, that can be studied from here. The four regions cut off in which both junctions, base to emitter and base to collector, are reverse. In this, it acts as an off switch. In saturation, both junctions are forward. In this, it acts as on. In active, this junction is forward and this is reverse. In reverse active, both this is the reverse of the active or forward active. So today our focus is on these two regions, cutoff and saturation, and how it works as on and off. This is terminal identification, which we do in the hardware. So we are leaving this now, and we are coming to these circuits, which are actually telling us that how we are going to implement them in multisim. So this is a transistor, and it seems to be NPN transistor because arrow is coming out. The output is seen at a LED. So output can be easily seen if LED is on. So transistor is on. If LED is off, transistor is off. This resistor is for limiting the current in the LED, and this voltage will work for this path, which is collector to emitter. From where we will control the input, that is this base to emitter junction. There is a fixed resistor and there is a variable resistor. The purpose of fixed resistor is to limit the current in case if the value of variable resistance is zero. So with the change in variable resistance, amount of base current will change, which will ultimately change the current in this collector to emitter path, and which will ultimately decide the transistor to be on or off. So this is for NPN transistor. Same is true for a PNP. So arrow is coming in. The values of resistance can vary depending on the configuration, are the type of LED that we are using. The only difference is that because it's a PNP, so its base is N, and we need to apply the negative voltage. So now we can see a negative sign in the voltage. So there are two possibilities, either to add a negative sign in the voltage, or we can make this battery in the reverse direction. So both are possible, and we will try to see these both in our actual multisim simulation. As far as activity is concerned, so we have to implement these circuits, and then we have to attach the screenshots of transistor in on as well as off. So NPN and NPN in off and in on condition. Again PNP transistor in off and in on condition. So let's start to build the circuit at multisim. Now there are a variety of transistors. We can take any of the transistor. So we know how to select a component. We will come to the category of transistors. In there is a BJT NPN, and we can take any of the transistor. Let's say we are taking the second one, 2N2222A. After taking the transistor, we have to take DC voltage for input as well as for output side. So for input side, the magnitude is 2. Output side, the magnitude is 5. We are following the circuit as per the diagram. Actually, this is a recording session. So we will try to do the discussions after this recording. Anyways, uh, this is the circuit which we are following right now for NPN transistor. So we need a fixed resistor and a variable resistor on this base side, and a LED a fixed resistor on this side. So again, basic category, a fixed resistor and a variable resistor. Particularly, this is potentiometer, which we have to use now. Okay. So let's complete the input circuit first. We have to give the input to the base from this mid terminal of the variable resistor or potentiometer, and this will be common on this side. Actually, this is common emitter configuration. So this emitter is common in input as well as the output. So here we have to attach one LED. So again, in diodes, there is a category of LED. We can take any of the color. Let's say we are taking red as shown in our uh, handout, and a resistor, again a fixed resistor, so we can directly take from here, and that's all. So making the values same as per the guided diagrams in the handout. Now what we can do finally, after adding a ground as a requirement, now what we can do, we can run the simulation. We will change the resistance of this variable resistor or potentiometer. So as we will change the resistance, the amount of current in the base will change. With the change in the amount of current in the base, the current in this path, that is collector to emitter, or the output will change, and that will ultimately make the LED on or off. So let's increase the resistance. Now, increasing the resistance caused the amount of current to decrease in the base, which ultimately caused the amount of current to be reduced in this path, and at this position LED has become off. So we can say this is the cutoff region for this transistor. Similarly, if we reduce the resistance, so current in the base is increased, which is caused increase in current in the collector to emitter path, and which has ultimately make the transistor on, and as well as the LED as on, which we can see from this indication. So this is showing the LED is on. We can now use the same circuit and just with a minor modification, we can make it a PNP based switch, a PNP transistor based switch. Okay, so what we have to do, we have to replace this transistor. So replace BJT PNP, again any of the transistor randomly, and either we can make this voltage negative. This is possibility number one. Possibility number two is if we want to keep it positive, so we have to change its direction. So it depends on us how we are going to do that. So let's again run it. Now resistance is lower, so base current will be sufficient, which is causing the LED to on because transistor is on. As we will increase the resistance, base current will reduce, and at a certain point, like at this point, base current is reduced so that collector current is also reduced, which has caused the LED to become off. So with this, uh, we have tried the transistor NPN as well as PNP, how they act as a switch. And similarly, we have to practice the same on multisim, either offline, or if we don't have the offline multisim, uh, the circuits which are attached here, actually they are made on the online or live multisim, so they can be implemented there as well, and it depends on your convenience.